There's no?
Yeah.
Cool.
Where would we go to get those?
We're talking about to do it this Friday.
That's what I'm saying. Well, I mean, reviews next Wednesday, so Carl's done my Friday.
Next Thursday? Next Thursday.
The recording software's on this computer.
Wednesday, right?
On this? No.
Oh wait, that's right. We have.
Yeah,
I keep forgetting that.
yeah, they've got some kind of.
We don't plan to come.
Chris was saying we tried to get it on the computers, but there's some kind of security or something that's not working out. Recording.
Do you have Carson's computer and stuff?
Yeah.
Where's it?
Right here.
Okay.
We're trying to save the video. Why does he need it?
Can I borrow this from you? Because I didn't use this right away. Thanks. I grabbed his bag and stuff.
Okay.
We'll get started here in a minute. Some of you were talking about you're not sure when the classes are meeting. We are meeting on Thursday, and we're also meeting on May 1st. I know some of them might conflict with thesis students because you have your defense on that day. But you know, we are recording, so you can catch up on the video. And I'm going to try to. We're going to close out this week with some of these tools of the curtain panel pattern-based, you know, families and the adaptive components, just showing you some tricks with that. On May 1st, I'm basically going to go over interior rendering and exactly how to put stuff onto an 11 by 17 sheet of paper. Because remember, Chris has the assignment where you're turning in 11 by 17 kind of construction documents. And I'm going to just show you exactly how we're, you know, kind of putting those together. And so that'll be basically the last lecture will be about putting together your construction documents. And also how to bring in this bridge that we're making in the conceptual design environment into your model. That might be important. Is this recording?
Yeah.
Okay. So, do we have everyone here? We'll wait one more minute.
Looks like there's computer. I think there might be one or two there missing.
You don't need your file from last time. We're just going to start with a new file because we're going to be in a new curtain panel pattern-based family, but we're going to be in the family environment. So when you're in the splash screen, we're going to be clicking here in families here in a little bit. This way you don't really need a USB stick. Okay, let's go ahead and get started. Under the families, when you're in your splash screen, let's first let's open up a new conceptual mass. So click on new conceptual mass. And again, we get to this dialog box that shows us the mass. Click on mass and open. That brings us into the environment where you know, I was just at with the lecture. I'm moving my do you not have a license up there?
No.
I might need to jump on another computer. Okay, so in this environment, all I want to do here real quick is make a just a flat surface that we can divide up, and then we're going to move into the curtain panel pattern-based family. So in this environment, I'm just going to draw a rectangle, and we're going to take this rectangle and we're going to extrude it up. So click on the line and hit create form. And then I'm going to select the whole entire rectangle and just click on divide surface. So we divide this up into all these different points. And maybe we should, I'm going to delete the top. Instead of doing all of it, let's just select the outside faces. It gets kind of confusing when we divide everything up. So I'm just selecting the outside faces and then going to click divide surface. And then we can divide this surface, instead of the default 12 by 12, perhaps we'll do something like 6 by 6. Or 6 by 8. I was trying to get it a little more square, at least on mine. So I've got this form that we've divided up. This is a solid form. It could be this particular simple form, or we could have a very complex form, kind of like our bridge path that I was showing in the lecture, that you could also divide up. But when you click on, once you've made a division, if you click on the actual grid, notice to the left, there's under the properties palette, there's a pull-down menu that's associated with all of these different types of patterns of how you can divide a surface up. So I could pick on like rhomboid, I could pick on triangle flat. Notice how with each time we make that division, we get a different kind of form or different shape that's associated with that face. The reason I'm showing you that is when we move into the curtain panel pattern-based families, they reference and use these same grids or these same patterns of how you can divide up a surface. So whenever you model a curtain panel pattern-based family, let's say with the template a third step, when you bring it into this particular environment, you have to have your face divided up with that same pattern type to eventually be able to select that curtain panel. You know, that'll make sense here in a minute. For right now, I'm just going to click on no pattern. And by the way, all of these patterns are predetermined by Revit, and you can't customize these patterns any further than the options that they give you here to the left. So I've got no pattern, and then we've got the U grid layout, and the V grid layout, the grid rotation, and all those kind of parameters are the only ways that we can adjust these grids. For the time being, they don't have a method to sort of customize that. I'm going to keep that open and click under View, User Interface, and Recent Files. And that'll take us back to our splash screen. And this time I'm going to click on New, and we want to click on Curtain Panel Pattern Based as our family template. It's right there kind of at the top. Click on Open. And you should have a screen that looks like this. You basically have these gridded elements. You've got 4 points and a green line that goes around the border. Now, if you click on the grid, you see that blue grid that's in the background. If you click on that grid, look to the left, you have a pull-down menu. And if you look at that pull-down menu, it's all of the same shapes again, or the patterns that were related to that last environment that we were just in. So I could change that grid, and as I change the grid, I get different points and different reference lines that are associated with the grid. Just keep in mind though that before you continue modeling in this environment, you want to set your pattern first. Because once you've made all these patterns and everything that's associated with this grid or this pattern, if you can't really change the pattern after that. Because there's additional points that are associated with different patterns, and there's different reference planes and so on. For right now, we're going to keep it simple and just work with the rectangle. And we're going to talk about how we can start to model some tectonic structure relatively quickly by understanding how to work with this pattern. First thing I'm going to do is just draw basically a pipe that goes around this pattern so that we can then apply it to our other project. In order to do that, what I need to do is click on our point element. We use this point element in the current panel pattern-based families, the conceptual mass, and then also adaptive components, adaptive generic components all have this point element. Once we select that point element, go ahead and click somewhere on one of the green lines so that this point becomes hosted on that line. I'm going to click on that point and select Show Reference Plane and click on Always. This way I can see that perpendicular plane. And then I'm going to draw a pipe or a section of a pipe on that plane. So I'm going to click on Circle, and these would just be model lines. So I've got model highlighted, I've got circle, but I need to make sure you do the placement plane and pick the reference plane that's associated with that point. And again, like I said, it goes back, defaults to the line command. I'm going to go back to circle, and I want to snap, and I'm going to tab over until I select the point as my center point, and then draw a circle. It doesn't matter what the size of that circle is at the moment. Next part is I'm going to create a parameter. So click under Family Types up here at the top left so that you get into your dialog box, and the parameter is going to be called, so I'm going to click on Add. I'm just going to call it R for radius, and length is fine, and we keep it as a type. And I'm just going to exit out of that, hit OK, OK. Keep the parameter set to 0. And then I'm going to select this circle, and when you select the circle, you'll see this temporary dimension shows up. My particular dimension says 1 foot 9 inches. If you click on the little symbol that's below the text, 1 foot 9 inches, or whatever your dimension is, that little symbol looks like a little dimension string icon. Once you click on that and then left click off into space, that makes that into a real dimension that we can then apply a particular label to. So now I can apply that R radius. And now I can make this something a little more like a pipe structure. It might be, for instance, maybe a 3-inch radius. And hit OK. So the reason I set parameters to everything is so that later on, once you make your form, you can just adjust the numbers with the dialog box and not have to go in and remodel things from time to time. The last step here to make this a pipe structure that goes around this whole entire form is to tab over until you can select that circle, and then hover over your reference line. You should be able to, because it's a reference line and it's all connected, it should highlight all 4 sides, and then we can select that and hit Create Form. Now before we are able to actually use this form, I need to save this, and I'm going to do a Save As Family, and we need to save this as some kind of name that we can find and reference later. So save it somewhere in a folder. And right now I'll just call this curtain panel. Let's call it in class for now. You might name yours a little bit more, whatever kind of design you're trying to make, you might give it some kind of name. But because this is a curtain panel pattern-based family, and we've got our other project open in the background, you should have this button up here that says load into project. So if I load this into the project, I now have this loaded into this conceptual mass environment. And now when you select your divided surface, and then click on the properties and your little down arrow here, and scroll down to rectangle, you should see the name of your pattern, curtain panel in class, underneath that rectangular template. So now I can select all of these and change this divided surface to reference that curtain panel. So you can see that depending on your initial template that you started with, if you happen to be working in a hexagon or arrows or any of these other templates like a half step or a third step, whenever you create your form and your curtain panel, it will show up underneath that template. So because we are working under a rectangle, that's why our name of that particular pattern ended up there. So what's nice about the curtain panel pattern-based family is that it is a parametric family automatically because it has adaptive points that were associated with the corners. So if I go to this particular grid and change the numbers, so I've got a fixed number, change this to 12, your form and your curtain panel will adjust, as you can see on the screen, and continuously manipulate and add and change and conform to whatever your grid happens to be. So if I were to change this to 45-degree angle, so you can kind of play around with that a little bit. So now once you've got that applied to a particular surface, and this could also be on a complex surface. So in this conceptual mass environment real quick, if everyone can go into, let's say, a north elevation, and I'm going to create two splines as kind of the typical Rhino exercise. I got this spline and I'm going to create another one. Doesn't matter what shape they are or what they look like. I made these two kind of complex splines that are crisscrossing each other. And then in 3D, if I take one of those and move it, and if I create both of these, if I click on both of these and then select create form, I get a lofted surface. So I've got this complex surface now. So you can see in Revit you can make pretty much any shape you want, just like you can in Rhino. And if I take that surface and divide it up and then apply my pattern to it, might take a minute here to think about it because it's got a, and now I zoom in, I've got my complex structure applied to that more complex form. So this could be kind of like a canopy or something that might enclose your bridge. So now once we have that particular form or that curtain panel, we can go back and start adding more things to it to make any kind of design that we might want. We can move in 3 dimensions. We can also keep this just planar. For right now, I'm going to just add a diagonal in the middle. Before we do that, we need to change everything to a wireframe. One thing that's very important while you're in this environment is that everything that you draw needs to be snapped to these endpoints or these reference lines, or they need to be hosted or referenced to each of these points. If you just draw something free form, not referenced to anything or not hosted to anything on this original setup, you're going to get all kinds of wacky things that would start to happen once you try to apply it to a surface that's being divided. So remember, snapping is very important. If you make a form and you end up applying it to a divided surface and it doesn't look right, it's probably because you haven't snapped to the right adaptive point or the reference plane. So I'm going to draw a diagonal, and I'm going to make this a reference line. And if I draw reference and then line, and before I snap, I want to tab over and make sure I'm snapping to the point. You should get the little point icon. It's hard to see up there, but you should also get a highlighted note that says point. And then I'm going to move to the other side and tab over until I get the point as well. And then I can, again, I'm going to make a pipe. So I'm going to, somewhere in the middle here of this diagonal line, I'm going to put another hosted point. So you can see how these hosted points are very important to the making of basically anything in this environment. And I've turned on my reference plane. And if you're having problems snapping, sometimes you might have to rotate around the view a little bit. And the last thing here, I'm going to draw a circle. And I'm picking this plane. And again, I have to pick on circle again, and I'm doing the same steps that I did on the other. And I'm also making that equal to my radius dimension.
When we click on the reference plane, it's selecting the plane and it's not snapping.
It's happening.
Yeah, Jeremy, I have like a big blue plane and I can't snap.
So you got reference and doing reference line.
That mouse is really sensitive.
Let me see what I was doing real quick. So you've got reference and you're choosing draw on face. Do you have draw on face selected?
Yes. Just don't know why this big blue thing is
I bet I- Turn on 3D snapping and see if that helps you out.
Yes.
Okay.
Thanks.
So if you're having trouble snapping to that point, I think some of you had this blue plane that was showing up. Up here, when you're drawing with the reference plane and the line, if you turn on 3D snapping, that should allow you to snap to those points a little bit better. Did that work for everybody? And all I'm doing here in the middle is making another pipe. So those same steps that you did for the kind of the border, I applied to the center as well. And so when you're done, you can save that and then load it into the project. And because you've already applied this to this environment, you can constantly overwrite. You can add more parts to this component, and you can overwrite, and it should update all of your surfaces. And looks like I did not snap correctly. So I've got a problem. If you look up on the screen, my actual diagonal is not snapped to the other point. This is where snapping comes in important. And I like to build these curtain panels kind of one step at a time because you want to test to make sure that it's working with each little addition that you do. And so I need to go back here, and unfortunately, when you run into that problem, you have to start over. So I'm going to draw this reference line. I've got my 3D snapping on.
Did it not work because 3D snapping was off before?
Yeah, for some reason, yeah, my 3D snapping was off, and I didn't get the blue planes that showed up. So yeah, 3D snapping, we always want that to be on. Let me do these steps real quick. So this will give everyone a chance to catch up. Did everyone else get theirs to work when you reapplied it? And so when you load into the project, you'll always be presented with this dialog box if you already have this component in there and you keep adding. You always want to overwrite the existing version and its parameter values, the second option down at the bottom. I think that should solve my problem. What's your error say?
Curtain family contains a shared family of the same name. Please rename the families before the thing.
Getting what?
Sounds like it's been over.
Do you have a nested family? Oh, I see. You guys accidentally. Now, redivide your surface. Somehow you accidentally.
Okay, it's like divided with the same.
Okay, did you get it to override? What happened? Yeah, what happened is somehow you've applied or loaded this into the same family. Like basically you loaded it into itself. So I'm gonna delete it out of here because it doesn't need to be in this family. And load it in the project. That should fix the problem. Now this. Let's see what happens here. Anyone else have any error messages or anything? Okay. So you've got this divided surface. So you basically had something similar like I was doing. You don't have it snapping to the right points. So you'll probably have to go back and rebuild that part.
Thank you.
All right. Okay, so you've got your kind of complex form. We've made basically a diagrid out of this curtain panel. One thing I want to show you guys how to do is how to make a sphere in this environment. And this would be, let's say, on each of these corners or one of these corners. And I'm just going to do it on one corner. I'm basically going to make like a ball that it looks like these pipes are, being connected to, kind of like in a space frame assembly. And in Revit, in order to make a sphere, it's a little bit tricky, but I'm going to go back into my wireframe mode. And I want to host a point, so I'm going to pick the point element, and I'm just going to host a point somewhere on this reference line. Doesn't matter which line you pick, just pick one of them, and I'm putting it somewhere near the corner point. Next thing I'm going to do is tab over it, and I want to choose show reference always. I wish there was like a default that would always turn that on, but unfortunately you have to do that manually each time. And I'm going to make another parameter here called sphere let's call it sphere R, or sphere radius. And now, in order to make a sphere in, or any kind of revolve, like any kind of shape that's a revolve in this environment, is not as intuitive as you would think. But basically what we need to do is draw a vertical line that would act as the rotational axis for this revolve. And I'm going to draw this on this particular plane that's associated with this point. And so I'm going to draw a model line. I'm going to click on placement, plane, pick. And it defaulted back to a point this time for some reason, so I'm going to click on line. And I'm going to draw a line from that center point, snapping to it. And if I turn off 3D snapping, let's try this. There you go. Make sure 3D snapping's off, and then you should be able to draw on that axis. Now I've got that line drawn where I drew it straight up, and I'm going to move it so that the center line, so I snap, I'll do this again. I'm going to select that vertical line, and I'm going to click on Modify Move. I'm going to snap to the center of it. You should get a little midpoint triangle. And then I'm going to move it down to snap to that point. Basically what I need is a line that's going up and down through this point. Next thing I'm going to do is draw an arc that is going to basically connect from one side of this axis, and I'm going to draw it down and make it connect to the other, kind of below this point. And I need to draw on this plane. So I'm going to click on center end arc as my drawing command. I've got the model line picked, and I'm going to choose pick to pick my plane. And again, I have to go back and pick this command again. And I want my center to be the center point. So I'm tabbing over until I get the point. And then I'm going to draw up and just draw an arc until it connects to the kind of top and bottom of this line. You want this line that's in the middle here to make sure that it extends past the endpoints of this curve. Before we continue, I'm going to select that arc and turn on those dimensions, or make those dimensions into something real. I click on that icon, and then make that equal to our sphere radius value. And then I can come in here and enter something like, let's do 6 inches. Everyone got those set of steps completed? Okay, so now if you select that line and then control and select your arc and select create form in solid, change this to a hidden line mode, you should be able to see a sphere created. So now when I'm done, I can select that point and move it to either a 0 normalized curve parameter or a 1. Basically it moves it to the end point. And so now I've got this kind of knot at the, kind of looks like a space frame connection where these pipes are coming in. And go ahead and click on save and then load this into the project environment. With each addition, it takes a little bit of time for it to think, especially because we've got this complex form that this thing is being applied to. And if I look at it in 3D, I've got this little space frame connection here now. Now I might choose to scale this by a formula. So as you change the pipe radius, perhaps you want that sphere to always be larger. So I'm going to type in an R and make this something like times try like 1.67. No. Let's do 3 times 3. So because I have all those parameters set up, we can set up that relationship to identify, change the radius pipe or thickness of my actual border pipe that's going around. My sphere also updates and changes. Yes. Make sure that that vertical line extends past your endpoints of your curve. So if you can click on it and then move the endpoints. Okay, you probably have to
If you select the point,
Control Z.
you change the normalized
Delete your curve and draw that again.
Yeah, and to do
So
that,
when you
if
do
you
your
go back to the
curve,
wireframe,
just
you
make
can actually
sure.
select that plane,
Yeah, do the center and arc.
and then change the normalized parameter
So tab over
to either 0 or 1. And then move your mouse back off the side.
It'll be a circle.
Anytime you do any changes on that side, it won't update until you move your mouse off that little box.
So click there, and then rotate down. As long as you touch the other side. So,
Right here.
yep. Double click. And now when you select your curve, so go to that modify, and then go cursor over there. Click on that, and then control click on the vertical line.
Do the same thing, you'll be able to set up and change it.
and then hit create form.
Do you get that?
I had to change the.
And now when you turn it to hidden line mode, you should see that as your hidden line mode down at the bottom. The hidden line. So when you're creating any kind of revolve, and that could have been any shape, but you know works best with the sphere, you really have to make sure that that vertical line that you're trying to rotate around, you know, extends well beyond the endpoints of the curve. Otherwise, it won't make that shape. And you notice when you're done, that line disappears because it was basically kind of a construction line. So the next part is we can create solids and voids within this space. And if we click on wireframe mode, you can select the reference lines individually. So I'm selecting one of these triangles. I selected the three edges of this triangle that's here in the middle. And then you can also say create form in solid form. But when you do that, you'll be presented, if you look up on the screen real quick, with two options of how to create this solid form. It's asking you here, basically what these two symbols are saying, is if you pick the one on the left, you're making this into an extruded form. If you pick the one on the right, you're making it into a flat plane. So I'm going to pick the one on the left for now. And then once I do that, I can click on my hidden line, and you can see it extrudes up at some particular value. But if I click on this mass that I extruded up, over to the left we get a positive and negative offset. And if I, just for right now, type in 3 inches on each one, basically what that's doing is making a form that is going to extrude above and below the grid line. I might exaggerate this a little bit more, make it 8 inches on each side. So you can start to actually make 3D components. You can get into this, and I'm going to load this into my project environment again. And so again, we're adding more parts to this this piece. And I think here in a minute I'm going to. It shouldn't take too much longer. So now you can look at this and again in 3D, and you can see how you can start to add all of these components. Now the key here is that now that this has been applied to this particular surface, at any time we could go back and edit, you know, the original curve. Let's say I come in here and I change any of these splines. You can select this point. You can see I'm editing this curve at the end, and when I click it, basically this surface is going to morph and change back to the new curve, and then also interpolate this curtain panel pattern-based family all the way across the surface as well. And so this would probably take a minute to make the adjustment. And so you can see that once you have this curtain panel and you've made sure that everything snaps together, you can continue to make adjustments to your form and to your architecture, and you don't have to worry about rebuilding this particular pattern over and over again. You know, if you're building this in Rhino and not using Grasshopper, you'd have to, every change that you make, go back and, you know, redo every little part. So that's kind of the nice thing about this conceptual design environment. It gives you the quick ability to make these adjustments. And I'm going to add a void now within this particular space. And if we click on this form, before I continue, I'm going to click on each of these corner points one at a time, and I'm just going to move them. I'm going to drag them up and down. I'm dragging them off the grid. And I'm doing this for a reason. The reason is, if you've snapped correctly, this is a way to test your panel before you apply it somewhere. If you've snapped correctly to all the different points in the pieces, your whole entire form should move up and down and not, become disconnected as you move these points away from the grid. By moving these points up and down, you're not moving this component into 3D space, because if I load this back into my project environment, it's not going to actually elevate off the grid. Those points are the adaptive points that are still going to be associated with your divided surface. Not sure what change I made that it has to rethink here. Okay, so now I'm going to make a void that cuts through this particular surface. And in order to do this, I need to make some relationships with some more points and reference lines to always make an offset. You cannot just make an offset. If you make an offset, it doesn't know what its original host was. You have to kind of make this offset yourself based on a set of reference points and hosted reference lines. I'm going to click on wireframe, and I'm going to make a couple points here. Let's see what I want to do. I'm going to make a point on this part of the triangle down at the base, on the diagonal, and I'm going to make another point on one of the legs, and I'll make, let's do this, yeah, 2 more points on the other side of the triangle. So I've got 4 points that I've created. So I've created 4 hosted points that are along this triangle, and I'm doing this on the part where we've created our solid mass. So make sure that you're working underneath your solid mass, because we eventually want to cut a void through it. I'm going to create a couple parameters here. I'm going to add a number parameter, because this is going to reference a normalized curve parameter, and it needs to be a decimal value. So I've got type of parameter as number, and I'll call this void offset. And I'm going to create another number parameter and call this void offset inverse. Excuse me. My void offset, I will, for right now, make it 0.25. My void offset inverse is essentially going to be 1 minus the void offset. I'll explain why that is in a minute. So basically, no matter what I change my offset dimension to be, I should always have a void offset inverse, something greater than 0.5, and also, it won't ever be greater than 1, because we've done 1 minus the void offset. Keeping it at 0.25, and I got 0.75 up there. I'm going to click OK. Then I'm going to select one of these points, and I'm going to look at the normalized curve parameter. If that normalized curve parameter is less than 0.5, I'm going to make that equal to the void offset. I'm going to click on all these. If it's greater than 0.5, it needs to be equal to the void offset inverse. So you kind of have to judge what those points, original points, are kind of telling you. And I'm setting each of these and I'm going to hit save because I've got that worked out. Now, the next step here is I need to draw a reference line between these points. So I'm going to click on line, reference line, and make sure 3D snapping is on. And I'm going to make sure I'm also snapping to each of those points. Hit escape when you're done because we only need to draw one at a time. The next thing I'm going to do is draw a couple more points on these new reference lines that we just created. On the one that's towards the base, I'm going to draw 2 points, and the one that's here in the middle, I'm going to just snap to the midpoint. If I snap to the midpoint correctly, if you click on that point, it should be equal to 0.5 as your normalized curve parameter. Then these other points that are down here, I'm going to make those equal to those same parameters that we already set up. If I click on this point and it's greater than 0.5, I'm going to make this the void offset inverse. I'm going to do the same with the other one. This one's less than 0.5, so this is equal to void offset. Now I should be able to move my points on the edges, and everything should move with it. If not, you haven't snapped correctly. The next part is I'm going to draw an inner triangle that connects all three of these points, and these need to be reference lines. I guess it doesn't matter, but I'm going to use reference lines. So click on reference. I've got the line chosen, and then 3D snapping. I'm going to make sure also chain is selected. It should already be selected. And I'm just going to make sure I snap to each of these points. And I want to close that shape and then hit escape. So I should be able to select a triangle that's here in the middle. We can test everything out, make sure you can change your void offset to some other value, and your triangle in the middle should also kind of move as well and change. Now the last step here is to make this into a void. So I'm going to select that triangle, and under create form, if you choose the down arrow, you can create what's called a void form. And when I select that, I'm presented with these icons down here at the bottom again. And we want to choose the one that's on the left because we want this to be a void that's kind of the solid void extrusion that's cutting through this particular space. So I'm going to click on the one on the left. And before I continue, I'm just going to add over to the left, you see positive offset and negative offset. Type in like 4 feet and 4 feet on either side. And now when I look at this in hidden line mode, I've got that void through that form. Now, one thing that we need to do is you always need to make sure that your void form extends well beyond the face of this 3D element, or this extruded element that you've created. If it's not cutting all the way through, it's because you haven't extruded this particular panel all the way through as well. But we should be able to now click on this and change, again, our offsets in the middle, and you get this form that's adjusting. I can hit save and then load into project. This might take a minute to calculate, but if you've done everything right, it should cut through that triangle and you've got another addition to this curtain panel pattern-based family. Need a minute. Look at it 3D. And now I've got this panel repeating all the way through. If we did not set up those hosted points to create that void, we would not actually really be able to do an offset. So everything that's related in the curtain panel based family has to always be set up with a set of hosted elements and these reference lines that are associated with either reference points or these adaptive points on the end. That's all we're going to do for today, but I wanted to show you that you guys can create these tectonic structures, and I could take this panel and remember what we did in the lecture. Before I dismiss you guys, I'm going to load the bridge that we were just going over. And because we have this particular path and I've divided it up into all these different surfaces, I could I'll just apply this to one side so we don't waste a lot of time. I might divide this up a little bit more, and we can take this curtain panel, load it into the project, and then I can apply. This might take a minute to maneuver here. But the point would be that as you change the parameters of this bridge and the different sizes, this curtain panel, because it's applied to this divided surface, will always update and adjust as you make your changes. So now I've got this, it's a little out of scale, but I can go back in and tweak my parameters, and I've got my curtain panel applied all the way across this particular path. So now when I look at my bridge, I've got a kind of a complex structure off to the right. Could be kind of a canopy or like a screening device as you walk across the salon from one side to the other. That's all I have for today. Because we're at the end of the semester, I'm not giving out homework assignments, but just realize that we're looking for some of this to be applied to your overall design. So you may want to practice, creating your own curtain panel. And I would recommend always using the rectangular pattern and then creating whatever you want. When you get into those other shapes and you get a lot more adaptive points, it gets a lot more complicated, especially when you start to apply it to a curving, complex surface, and you run into a lot more errors. So if you can make whatever you would like out of a structure that's in that rectangular format, you're always probably going to do pretty well. So try not to venture too far out of that template, but you might just try to practice a little bit, see if you can make your own component and then apply it to the surface. And you could even try practicing this lecture that happened to make this bridge with the twisting form and so forth. That's all I have. See you guys on Thursday. Do you have a USB stick? So that I can transfer this over to you guys?
Not work on this.
They're not visible.
They're not visible.
They're not visible. But I don't know why the 3D printer is showing so many errors.
That's really strange.
It doesn't probably be saved to the desktop.
It's pretty much an order.
Yeah, it should work. You got space on it?
Oh, yeah.
Yeah, the actual, like.
We'll probably stop the, unless you guys want to record. 2 green.